So determine any non-permissible values, any asymptotes, determine the domain, and then we're going to actually graph these as well. So same thing as before, and this sort of sets up the pattern. The first thing you're always going to do is factor. What factoring does is it allows you to see if anything cancels out, and once you list your non-permissible values, so I'm going to put a 1 here just off to the side to say this is always going to be the first thing that we're going to do. Or should I put the 1 with the factoring and have this as a 2? What do you prefer? Is 1 okay here okay? So non-permissible values, x can't equal -2, x can't equal 2.
Sorry for interrupting.
Hello?
Would Randy Jensen say something?
So, there's our non-permissible values. Are they vertical asymptotes or holes? They're vertical asymptotes. You have one vertical asymptote at x equals -2 and another vertical asymptote at x equals 2. Second thing that we look at, horizontal or oblique asymptotes. You find that out by looking at the highest power. The highest power is an x squared. We have no x squareds on the top. That's equal to 0. Ha! Horizontal asymptote. Yes, you can have a vertical asymptote and a hole. So yes, that has happened, and that would you'd have a thing on the bottom, and one of them would cancel out, but the other one would stay, and then you would have a vertical asymptote and a hole. So we got y equals 0 as our horizontal asymptote. No oblique asymptotes. So now it says verify with graphing technology. We're going to graph this just to get more practice graphing them. We can label our 2 vertical asymptotes, -2 and 2. Label our horizontal asymptote at y equals 0. If we want to find out if there's anything on this equation, find our x-intercepts and y-intercepts. Y-intercept is plugging in 0 for x. That's easy. Can you see that that simplifies to be -4 over -4, which is just 1. So there's 1 point. Do we have any x-intercepts? Well, if we were going to have an x-intercept, that would be where the top is equal to 0. And that is at 4. Cool. This graph is going to get a little crazy. Okay? So we have our information so far, some stuff that we know kind of from this graph. We only have that one x-intercept. So as far as this middle section goes, this has to go towards an asymptote and up, otherwise we would have another x-intercept. Also on this side it has to go up. I'm not certain for sure that the lowest point is at that one, but since it looks symmetrical, I'm going to guess that it is. And you're not going to be required to know that it's more specific than that. Okay? If we go less than -2, so if I plug in -3, if I plug in -3 in the top, do you see that I'm going to get -7? And if I plug in -3 on the bottom,
For interrupting again.
hello,
Did Randy Jensen come back to class?
not yet.
Okay.
So we have the point right here, -3, -7 over 5. That tells us in this section, this is what has to happen, because it can't have another x-intercept. The problem on the right-hand side with having this x-intercept there at 4, we don't know if it's going to go up or down. So we have to try and plug in a value of 3 to see what's going to happen there. So when we plug in 3, can you see that you'll get negative 1 over 5? Negative 1 over 5. And once you have those 2 points, it goes down like this. What we don't know next here is, I'll show you with the pen that disappears. This part could either go like this and then flatten out, or it could bounce off and then flatten out. It has to go to the asymptote as it goes to infinity. So one of those two things needs to happen. So if we want to check what it could be, we could plug in 4. If you plug in 4 into, yeah, 5 would be, that's what that number is, 5. Perfect. If we plug in 5, well, this will be 1 on the top, and on the bottom we'll get 1 over 21. So that means we're going to get a little point above here, so it will go up and then flatten out after that. Because there's an asymptote that it has to approach. And what that asymptote says, as you get to very, very big numbers, if we look at the equation and we think x is big, on the top of our fraction we have x, big. On the bottom of our fraction, we've got, no, this is our equation, right? And we're thinking of x being a big number. So on the top we got x, and x is big. So it's feeling pretty big up there. But what do we have on the bottom? We have x squared. What does x squared think of x? Small. Because x squared is bigger, right? If x is a big number, you're like showing off, hey, I got a $100 bill, right? You pull out, oh, I got the $10,000 bill because it's x squared. Well, there's no such thing. But it's bigger, right? So the bottom gets bigger faster than the top does. And because of that, it approaches our asymptote at 0 in the end. All right, let's do part B. Oh, the domain. So the domain, okay. The quickest way to do the domain is say x can equal 2, x can equal negative 2, but x can equal everything else. I know. We got one more. We can do part B. Oh, yes, we can. Part B. Oh, B is a beautiful equation to graph. Doesn't it look nice? First of all, it's 2 difference of squares, so you get to have so much factor fun right at the beginning. Look at that. Step 1. Non-permissible values. X can't equal negative 3. X can't equal 3. Are those vertical asymptotes or holes? Vertical asymptotes at x equals negative 3 and x equals 3. Step 2. What's the highest power? X squared. We have an x squared on the top and an x squared on the bottom. This simplifies to 1. What does that mean? Horizontal asymptote. At y equals 1. That's a bad looking A. Nice. And so now you could start graphing. we have at 1, 2, 3, and 1, 2, 3. There are vertical asymptotes, and they are labeled and at y equals 1. Two minutes. Awesome. Well, let's keep going then. So when x is 0, what do we get? 4 over 9. Do we have any x-intercepts? We have x-intercepts at -2 and 2. Nice. We still need a point when x is bigger than 3 and when x is less than -3. So we'll plug in 4. What happens when we plug in 4? We're going to get 12 over 7. That's in this section, so this goes like this. And what happens when we plug in -4? -4, we get 12 over 7 again. They're playing tag. Yay! We're done. Okay. Questions 9 to 72? Oh, I'm just kidding. I'm just kidding. 9 to 10. Oh, and the domain. We didn't do the domain. The domain. X can't equal -3. X can't equal 3, but x is everything else.